Okay, so let's get started. So first of all, a few reminder that we don't have homework this Friday. So it's good news. The homework 5 is due next Friday. Just a quick reminder. And the homework does contain a little bit about what we're going to cover today. So today we're going to talk about data visualization, which is one of my research interests. So I'm very excited about covering this topic. Next lecture, what we're going to do is we're going to play with interactive data visualization system that actually my PhD student developed in collaboration with industry to explore biases in word embeddings. So it's going to be a fun interactive session. So again, next Tuesday, please bring your laptop with you. So we can kind of learn biases through interactive visualization. Okay, so today we're going to go over again Jupyter Notebook and to go over some of this basic visualization you can do through Python. Okay, so the Python data visualization environment, sorry to say, it is a mess. Not because it's not powerful, but because there's many standards. So if you look at this comic, it says we need to develop one universal standard that covers everything, every use cases. And as a situation there's 15 competing standards. So we're going to go through 3 of them today. And that you're not going to come out of this lecture to become an expert in data visualization, but the goal is for you to be able to use of those fundamental capabilities that Python has to offer. So a lot of visualization capabilities in Python are built from matplotlib and its extension. So surrounding matplotlib, there's also the pandas, which we're going to see today. And then there's also Seaborn. And then those are the 2 things we're going to talk about. And also it's occurred to me that being a nerd, that forever you're going to change your vocabulary, because now if I tell you Python, your first reaction isn't an animal, but it's a language. If I tell you panda, your first reaction is data frames, not panda. But anyway, side note. There are also web-based visualization tools, becoming pretty popular are Plotly. And then there's Altair, which is based on Vega, which is an interactive visualization sort of language, sort of syntax. And we're going to see a little bit of Altair. The interesting thing about Altair that is different from the other things is offers a lot of interactive capabilities. So it's a bit more powerful if you want to create costumed visualization. So I want to make a small distinction about sort of the libraries you're going to see. They're roughly clarified into 2. One is sort of plotting library, and one is drawing library. And plotting library are pretty much you are using existing charts, and drawing library allow you to create something that is not exactly out of a box. There's some questions. Okay, good. Feel free to unmute yourself. I don't see exactly if I have a TA online. Is my TA here today? If not, please unmute yourself and interrupt me because I can't really see the chat. All right. Okay, so, and again, if you want to create even more visualization, and if you find visualization to be very interesting, there is D3.js, which is a JavaScript-based sort of library to create visualization. In the fall, typically there is introduction to data visualization, which is cross-listed as undergrad and graduate level course, and that will go into detail over D3.js development. So let's start with matplotlib. Okay, so let me make sure all my output is turned off. Okay, so it's pretty much follow along something you would typically see with MATLAB. And the syntax is, again, you're going to import, matplotlib as this and simplified as PLT. So you can call that particular library. The specific one that I want to emphasize here is when I say matplotlib inline, is just to say I want to show the visualization in my Jupyter Notebook. And in this particular case, I just created a data array, which is just the Fibonacci number, 1, 1, 2, 3, and so on. And I just want to plot it. And so if I actually want to plot it, I call the library.plot and provide my data. It's going to take a while. Why is it not running? Oh, yes. So this is what this looks like. So it's a very simple line plot of the Fibonacci number, okay? But you can also assign, of course, this figure to a variable. So this is nothing interesting, just tell you it's created a figure, and that figure size is 720 by 720. Now, we can also do things like subplot, okay? And then this is a very, very simple subplot. If you look at this syntax, I just said, I want to create a figure, and then the figure size is 10 by 6. And it's a subplot, and then this syntax means that I'm creating a grid of 1 by 1, and just give me the first figure from this. And then this plot is, again, my Fibonacci series. So nothing has changed, but this is actually in the subplot environment. If I do a little bit more, once I plot, I can also add, again, this is a subplot 1 by 1, grid, and return the first one. But I can also put title, and I can put x-axis and y-axis label. So that is just sit x label, sit y label. And you now see this whole plot is called my line chart. And I have my x-axis and my y-axis, okay? And feel free to interrupt me anytime. Now, let's do a little bit more. Remember, I can plot multiple subplot. And what I'm showing here is I'm going to create 3 different plots. And I'm going to try to sort of put them together. So let me run this, and I will come back and explain. So what happened is that I now have created 3 plots and combined them into one single plot, all right? So what's happened here is the first plot is the Fibonacci series, which is showing here in blue. The second one is, who can tell me what this do? Yeah?
It's Fibonacci, but it's reversed.
Exactly. So yeah, so I'm just creating some toy data. It's the same Fibonacci series I reverted. And then the last one is I actually created a sort of array of 9 numbers. Oh, each one of them is 10 times 9. This is just, I'm plotting a straight line. So all 3 of them, one corresponding to the blue line, one is inverse of Fibonacci, and one is the straight line at location 10. And then there's a little bit syntax thing here is that what actually this returns has multiple entries. I'm just getting the first one, which is corresponding to my actual plot itself. And then the last bit is I'm going to specify my legend. So again, because I have 3 plots, I'm going to say the first data set corresponding to legend Fibonacci rising. The second one is Fibonacci falling. The last one is constant. So you can see this little box, which is created with this legend. Okay. Now, alternatively, you can also, instead of doing each plot and combine them together, you can actually making them in one single call, but it's a little bit long. So again, you are going to specify a plot. You specify the title, x-axis, y-axis. Now the most important line is, is this highlighted line where I'm creating a plot, but this plot actually have 3 different plots combined. The first one has a range. This is specify the range of the range of my value, and then this is my function value y. So this is my x value going from 0 to 8, and then this is my Fibonacci series. This is a second plot I'm doing, which is again x-axis from 0 to 8, and y-axis is the decreasing Fibonacci series, and the last one is from x-axis from 0 to 8 and constant or of value 10. And then what I do is I return it to those 3 different plot names, and I plot as before. So this will give you exactly same type of output. It's just your code is much more compact. So this is the same thing as you see. Now let's move forward. You can do multiple subplot now. I will specify entire figure of the size 10 by 8. Now, when I call this add subplot, I'm saying I am going to create a grid that is 2 by 2. So there's going to be potentially 4 subplot. And I'm going to specify my first subplot, my second subplot, and my third subplot. And then for the first, and when I plot this, what you see is let's go with this line first. I'm going to say subfigure 1 is upper left corner. I'm going to plot it, but in this case, I just created some dummy data, which is basically number from 0 to 9. So I just added this subplot right here on the upper left corner. The right one, which is subplot at 222, is this one, and that is my Fibonacci series. And the last one, subfigure 3, is this one. And then there's a little bit syntax. Number one, I'm using this k dash dash to specify my plot is now using dotted line. And then I have this specific value 3462. So what's different from the syntax, of course, you can also do subfigure 3.plot to plot this. But if I do plt.plot, what it does is actually looking at the last figure that is used. So the last figure you specify is subfigure 3. That's why this one is plotted as the third one. Okay. So you can do the same thing as before. I can create, so this is a slightly different syntax, but again, it's produced the same thing. So I'm going to create sort of subfigures in a grid of 2 by 2. And when I say 0, 0, it means upper left corner. 0, 1 means upper right corner. 1, 0 means the second row, the first one, and so on. So this actually produces, again, the same result as before, right? But of course, the last one, I did not specify what it is, so it's empty. There's no plot right there, okay? But you can also change the syntax slightly, and then this is again producing the same plot. Okay, and in this particular case, again, you notice the slightly difference over the syntax, but again, it's plotting each individual subplot. All right, so next thing we're going to talk about is how do you create some of those common plots. Number one, scatter plot, bar chart, pie chart, box plot, histogram, and violin plot. Okay. So this piece of code is a little bit long, but let me first plot it and we'll come back and explain what you are seeing. Okay, so now I have give you 8 of different plot, and then that's what this corresponds to. The first one is a scatter plot, I believe. Yeah. So if you see here, it says scatter, and I created some sort of random data. This is a 2-dimensional point cloud. The x-axis is from 0 to 9. The y-axis is from 0 to 9 reverse. So when you plot the scatter plot, it's basically plotting each data point along its x-axis and y-axis. That's why you get this sort of point cloud right here. That's a scatter plot. This one is the bar chart, and it's horizontal. So it's vertical versus horizontal. So if you actually look at this, it's this one is specify. The first array specifies the x position. So 1, 2, 3, there's 3 bar. The y position indicate the height of this bar. So it's 4, 2, 3. So if you look at this, this is height of 4, height of 2, and height of 3. So that's how the bar chart looks like. The next one is horizontal bar chart by just bar h. Again, you specify the range, and you specify sort of the length of the bar. The last bit, the tick labels basically label each of the bar. So in this particular case, I want to label each bar A, B, C, D. Well, actually ACBA depends on the actual function value going from bottom to top. Okay. So the next one is a pie chart. So I assume people have seen pie chart before. Again, you provide the corresponding label. And in this specific one here is to say, I want to display percentage, but I only want to display the 1 digits behind the decimal point. So that is sort of the formatting. So you get this pie chart here that shows essentially the market share Probably is a made up probability because this does not show the actual market share. But pie chart has been widely used, but there actually are some problems associated with pie chart in certain scenarios, especially when you have too many categories. The pie chart can become no longer sort of informative. So you want to, typically when you use a pie chart, you only have sort of data items to be like less than 10. Beyond that, the pie chart is not very informative, but there's other problem associated with pie chart. There's also box plot. So box plot, if you are unfamiliar with it, box plot has a, I just show you the Wikipedia page here, is essentially using the box to show the median, the mean, the max, and first quantile, third quantile. And how it looks like is like this. So this red line here is median and so on. It basically shows the distribution of it. So in this particular case, we created two random distribution. One is called large distribution, one is called small distribution. And those distributions were created with a bunch of random numbers at the beginning right here. So what this shows is that I provided two distribution. For each distribution, it shows the distribution with a bar chart. The next one you should be familiar with is the histogram, right here. And here I did not specifically provide the number of bins. So when you don't provide the number of bins, Python is trying to learn by a default number that adapt to your data distribution. Of course, you can specify the number of bins as well, okay? And the next one is, maybe you have not used it as much, but it's actually quite good. It's called violin plot because it looks like a violin. So again, in this violin plot is like a box plot. It shows, again, distributions. So in this specific case, it uses exactly same data as a box plot, but it's actually using a little bit of kernel density estimate to showcase the distribution. Again, there's a Wikipedia page that goes into a little bit detail over violin plot. So one way to think about it is like a variation of box plot. Okay, the last bit is I can modify those plots. For example, in this particular case, I am going to do a violin plot. But I'm going to kind of use the horizontal version of it, but also I'm going to only show a subset of the visual encoding that is coming from violin plot. For example, the typical violin plot shows a global maximum and global minimum, and I don't want to show that, so I can do show x extrema equal to false. That means I don't want to show the largest or the smallest number in my distribution. So you get something like this to the very end where my mouse is pointing. And also when I said vertical equal to false, that means I make my violin plot into a horizontal violin plot. Okay, next one is heat map. There are two separate ways to implement heat map in Matplotlib. One is called pcolor, one is called ImShow. And they kind of work similarly, but specifically ImShow works for images. So technically you can think about an image as sort of a 2x2, sort of like a two-dimensional array, and then you can use this to visualize images, okay? So whenever you talk about a heat map, you need to specify a color map. So let's first, let me first generate some data, and I'm just going to plot it right here. So this is a standard sort of heat map. And whenever you specify heat map, you need to do what's called sort of the color map. So in this case, I'm using this blue color map. So you can see the sort of the darker corresponding to bigger value, lighter become smaller value. And then again, you can just plot it using this command right here. And of course, there is one thing I want to point out is that in a lot of cases, when you are actually doing this kind of plotting, you can use what's called color brew to get what exactly the color map you want to use. So for example, in color brew, I can say, I can kind of play with essentially different type of color maps, and it will actually also output the name of the color map. So you can kind of play with color blue to figure out what is the color theme you want to use for your visualization. All right. So as I said, there are different color maps. So if I change my color map to be the hot color map, you get something like this. Okay. And And you can, of course, do, like I said, this now here, the PUBUGN is a color map that is coming from color brew. So for example, this is where the name is. This is YLGN. So let's see if we can change that. So this is now the color map that I just choose. Okay. So now you can also do some sort of style. And then essentially the first type of style is the style of ggplot. So basically, if I use this style, my plot is going to look very similar from the R library. So this is how it looks and appear for those 8 plots I have. You can change it to Seaborn. And the Seaborn has a different, slightly different color scheme and appearances for those different type of plots. And finally, you can also say, I just want grayscale plotting. Then everything is black and white and gray. Yes?
Sorry, this is on the thing that was just there before, but we used 2 different functions. One was like in show, and then the other one was p color.
Yeah.
Like, what's the difference?
Yes. So they pretty much do the same thing as they plot a heat map. The major difference is that IMShow is typically used for images. And for images, the axis, sort of how you read the images, is the origin is at upper left corner. So from 0 increasing, from 0 increasing. That's what IMShow assume the data is coming from. If you're using the other one, the P color, the origin is at lower left corner. So you go from left to right, increasing, from bottom to top, increasing. Yeah. And also, if you're manipulating images, you should use IMShow. But if you can see these 2 things, while I'm using P color, right, with this, versus I'm using IMShow, in this particular simple data set, this data set is highly symmetric too. There's really no difference. Yeah.
And so when you're using like a matrix, I guess, if that's like would you normally use image show?
It doesn't really matter in terms of, my answer would be if it's just a data matrix and you want to show a heat map, both will work. As long as you remember where the origin is for your data, right? What is the expected origin of your data set? Yeah. And typically people like to use the IM one for images. Yeah. Okay, so now we're done with styling. Let's move on to Panda. I know hopefully now Panda is your best friend because you have been using data frames. So Panda itself has built-in capabilities. So let's just read some data set. The movie data set, as you've seen before, right? The name, and rating and so on and so forth. This is just, we just load the movie data set. And I can do the same thing. So I can plot a line chart. So in this case, I'm going to do a little bit filtering. I'm going to look at my major movies who has more than, say, 500 votes and so on. And this is the type of line you actually have seen before. We did a little bit plotting the last time we talked about Panda data frame, right? This is just, just to, plot line. So it's line plot. It's also come with histogram, right? So if I just want to look at all the ratings and plot it using a histogram, this is what you get. You can also, put a little bit label. So you say, I'm going to label it by rating, okay? And I can also now, instead of, I want to also deal with a high dimensional data set. In this case, again, I'm going to read a CSV file. Iris data set is a classic machine learning data set that is 4-dimension and describe the iris flower. And this is how I'm going to plot the 4-dimension of the sepal and petal, the length and the width. And in this particular case, what's interesting about it is that this data set comes with 4 different classes. So when it's actually trying to plot the histogram, it's actually plot the histogram of the distribution of 4 classes together with this. So in a way that you can see the code is slightly shorter because it's come with sort of Panda dealing with data frames. Okay, so, and also I can also do kernel density estimate. That means for each of those distribution, which is the histogram is a sort of coarse approximation of a distribution, I can kind of replace it with kernel density estimate, then what you get is this kind of curve. So again, this is for the movie for kernel density estimate. This is for the 4 classes, right? So if you compare the kernel density made plot with this plot, the difference is that it does a little bit smoothing of the underlying data. So you replace the histogram by a kernel density estimate curve. Yes.
So you're just saying the kernel density estimate is just
well, it's actually a slightly thinking about a more refined representation of the underlying distribution. So if you think about plotting the histogram, you need to choose a number of bins, right? So as your number of bins increases, that your histogram is going to approximate this shape, okay? But kernel density estimate also has a little bit smoothing effect as well. Yes?
What does the alpha equals 0.7 mean?
Alpha, which line?
It's, above this plot here.
Oh, yes. So if I do this, which you're also going to see another example, it's opacity. Okay, but this actually will show up again later when I talk about scatter plot. So the idea of opacity is that I would like also, sometimes when you plot on top of each other, you no longer have a good understanding what is the density of points over there. So you want this opacity to actually show you where the dense region are where your data lie, right? If there's no opacity, if I have, say, 5 data points plotted on top of each other, you actually wouldn't know there's 5 data points. But if you have opacity included, it will actually highlight the density there. So it will have a higher density. That's really rough picture. Yeah. All right, so you can do bar chart as before. And so again, I'm going to just choose 10 movies for now because I don't want my data set to be too big. So my bar is like, 1,000 bars. So I'm just going to choose some 10 movies and I'm going to plot bar, right? So the kind is bar, and then I specify a title. And I'm also only going to show the rating, the bar chart rating. This is how it looks like, okay? So for the 10 movie, and also what's interesting, it says I'm actually choose subset of rating, but it actually shows the actual movie names on the x-axis. Okay. The next one is I can also group bar charts together. This is becoming slightly more powerful than what you have seen so far. You can combine 2 bar charts together. So what this does is, think about this is, I don't know, somebody's looks more like pressure, the blood pressure, for example. You have, you are using horizontal bar. And in this particular case, you have sort of those, you have, the Robin has, the data 140, 150, and, Katie has 120, 130, and Chuck has 110, 110. So remember, this is data frame. So you basically have an index and have the corresponding data set associated with this index. So that's why you have 3 groups of bars, and each shows, the data associated with, the BP1 and BP2. And then this is putting the bar adjacent to each other, but you can also stack them together. This is how it looks like. So when you specify the parameter should be stacked, it says true. But of course, for this particular data set, it may not make sense. But so for some other data set, for example, you have the 2 country and you want to stack their, say, corn export, then you can probably stack them together to look at combined export of their product. So this actually shows quite a bit when you want to accumulate the data across data point, the value across data point. So you can kind of combine the bars together. Now let's look at scatter plot. Remember, scatter plot, we're showing here, I am, because I have movie set that has multiple columns, I'm going to plot for each movie its year against its rating, okay? And I'll specify my figure size. So in this case, this is the scatter plot looks like. Again, x-axis is a year, y-axis is a rating. As you can see, of course, there's a lot of movie produced in the early 2000 versus 1920. So each dot here is a particular movie. Now this is where alpha value comes in again. So you see this extra field here is because actually where you see right here where my mouse is circling around in the early 2000, there's a lot more movies that is actually produced around that time that is plotted on top of each other. So in this case, when you change the opacity, you actually see that there's a lot more data points over there. So that's just a little bit highlighting, kind of overlapping points. So you get a more sense of where the majority of the data lie. You can, of course, do box plot. So I just do plot.box. Again, this is just choosing the rating of all my movies. I get this box plot. Okay. And finally, we can also create sort of, this is a slightly more involved. In this particular case, I want to create box plot, but I'm grouping box plot by year. All right. So let's look at this particular thing. So I am specifically, I want to do box plot, and I'm going to focus on the data rating. But then specifically here, this is actually one say I want to group my data by the year. So I am, for every single year, among all the movie that's produced in that year, I'm going to create a box plot. Okay, and then there's some other configurations I do, but what you end up getting is that you group the movie that is produced, say, in 2005, and among all of them, there's a collection of ratings, and I just plot the distribution of all the movies that are produced that year. So as you can see, with a fairly simple one line, you can actually create quite complicated box plots this way. Okay, so oftentimes when you study multidimensional data, we are going to talk about what's called scatter plot matrix. So, again, you want to, first load it up from Panda. And then this case is I am going to use the movie data set. So what does this do? This is saying that there's 3 dimensions of my movie data set I care about: the year, the length, the rating. And for each of the subplot, it's a scatter plot or it's a histogram. Okay, so actually this is scatter plot. They're all scatter plot. This just looks very dense. Sorry, it looks like histogram, but it's not. It's actually scatter plot. This is basically saying that I am going to plot year against length of the movie, year against the rating of the movie, and length against rating. So that's why there's a 3x3 plots in this here. So basically, when you do scatter plot matrix, you basically look at, for all the selected dimension, you do a pairwise scatter plot and put them together. So each individual sub figure is a scatter plot, and you put it together, it's called scatter plot matrix. You can change, you can use, instead of scatter plot, you can also change some of them to be kernel density estimate, okay? So in this particular case, when you specify this to be kernel density estimate, you will see a plot right here like this, okay? And you can also create, you can also, in the scatter plot matrix, you can also specify different classes by color. Remember, I have iris data set, which is this flower data set. There are several classes. So in this particular case, what I'm going to do is I'm going to specify each type of flower a specific color, or those different type of flower correspond to different iris species. So in this particular case, because I specify the color, then we actually try to plot iris. It's going to highlight for each of those classes a different color. Okay, so this is, remember, iris data set is the one that has 4 dimensions, which is the sepal, the petal, their length, and their width. So this is, again, a 4x4 scatter plot matrix, and I color the specific color for each class. Okay. All right, so I think we're at the midway point. I will give everybody a 5 minutes break. We will resume at 4:20. All right, let's resume. So sometimes you might not want to use the matplotlib. So alternatively, you can use what's called the Seaborn library. So the Seaborn library has some of the plotting capabilities, and we're just going to give example of those. So again, you're going to import the library, you're going to set some default theme, and then in this case, I'm going to load a data set that into Panda data frame, which is tip. So it says, okay, whichever bill, how much tip it is, whether the person is a female or male, whether it's a smoker or not, whether it's dinner or so on and so forth. So this is a data set we want to plot. And then the first thing we're going to do is scatter plot. But somehow in Seaborn, it's called relational plot. It's exactly the same thing. It's just the syntax they call it relational plot, REL plot. So in this particular case, what I want to plot is I'm going to use my data on tips. I'm going to label x-axis total bill, y-axis tip. I'm going to actually plot, in this particular case, the total bill against the tip. And then I'm going to specify whether it's a smoker or not. So the underlying, of course, this is a toy example, but the underlying idea is that whether there's a difference between the tipping amount, whether somebody smokes or not. So in this case, if it's a yes smoker, it's blue. If it's no, it's orange. That the plotting pick up color by itself, and then the size corresponding to the amount of what is the size? Yeah. So I can the size corresponding to the amount of tip, I believe. All right. The next one is you can also do categorical theme plotting. In this particular case, I am going to, again, plot bill versus tip, but I'm going to divide it by the day of the week. So this is Thursday, this is Friday, this is Saturday, this is Sunday. And specifically, the way I can break them into separate plot by day is I specify I'm going to use the column day. So when you read the column day, so I'm going to kind of bing my data into different day of the week. Now, the next thing you're going to do is you can also do what's called a categorical plot, specifically the strip plot. In this particular case, again, we're going to group them by day of the week. So Thursday, Friday, Saturday, Sunday. As we group my data like this, for each of the day, I'm going to plot separately between smoker's total bill and the non-smokers total bill. So, this strip it's called strip because the data is lying along a strip. Okay, so it's just showing the difference between different subpopulation, if you could imagine that. So for every day, there's 2 subpopulations, smoker, non-smoker, what is their corresponding data? So this might be useful if you want to investigate class differences in your data set. There's also what's called SWAN. And this data set is slightly different than the strip plot. It's basically try to avoid overlaps in your data. So when there's like data point that is too close to each other, that they have a similar value, let's try to kind of separate them a little bit. So you don't plot on top of each other. And of course, you can also do violin plot as before. So you just to say, I want to use violin plot, again, group them by day. And for each day, smoker versus non-smoker. For example, you can say, on Friday, looks like, on average, the non-smoker gives a higher, bill than smoker, and so on and so forth. So you can kind of plot it differently of the same data set using different style. And now I'm just going to show a last bit is you can actually plot on top of each other. It's called joint plots. So this data set I'm having is called penguins. This is a penguin data set. And then this is what's interesting is because, okay, so I'm going to say it's a joint plot. And I will specify my x-axis, my y-axis, which is a flipper length and the bill length of the penguin. And then the hue is based on species because there's multiple species of penguins. So when you specify hue, same thing as smoker, because there's smoker and non-smoker, it's going to assign different color to different type, so different class. So in this case, there's 3 classes, so I have 3 color. And then because it's called joint plot, it showed the scatter plot of those 2 dimensions against each other, but also it shows sort of the distribution along each of the dimension using something similar to kernel density. So, so sometimes you can think about this as a joint distribution, and these are the marginals if you know the statistics behind it. Last week, you can also do scatter plot matrix, but in this particular library, it's actually called pair plot, but that's the same thing as scatter plot matrix. So in this case, I'm going to plot the scatter plot matrix here. And again, this is 4 dimension, right? The bill length, the bill depth, the flipper length, the flipper depth, very similar to the iris data set. So again, you plotted the scatter plots. There's 4 by 4 scatter plots in the scatter plot matrix. All right, so now with the remaining time, I actually want to spend quite a bit of time on Altair. So this is again, one of those plotting libraries that very much goes into a bit of interactive capabilities, okay? And if yours doesn't run, you might have to install it on your computer. So again, you import this library. And first of all, I'm going to again read my movie data set. And in this particular case, I'm going to show, like the movie name, the genre, release date, average rating, how many watches it has. Okay, so you can have now what's called basic charts, and it's a little bit taking a little bit getting used to what you see here. Let's kind of interpret this. This is saying that, okay, I have my movie genre as my data set right now. Okay, and this is sort of the sub table from my original movie data set. And I want to kind of mark point, meaning that I want to use the specific glyph, which is a circle, to plot my data. And I haven't specified anything else, so it's just going to plot them on top of each other. All right, so that's what you see right here, right? They are plot on top of each other. So it's not very useful. So now let's say, it shows all the movies on top of each other, but now let's make it into a slightly more useful. I'm going to encode the column. So I'm going to use the average rating of those movies along the x-axis. So I'm going to stretch it out, right? Different movies going to have a different average rating. So I'm going to basically plot them along a single line. So that's what you get. because I initially didn't specify, now I specify the x-axis. So each data point, this circle is now a movie, and then the x-axis is corresponding to its average rating. So I kind of spread out my data point. Of course, there's different shape of my point. When I say mark point is this kind of hollow point, I can do circle, I can do square, I can do like, other things. So there's many other kind of syntax you can specify, or glyphs you can specify. So for example, if I say mark tick, right, I replace mark point by mark tick. What you see here is now my glyph for each movie is now just this tiny bar, right? The tiny tick that goes around. So it might be a bit more informative than circles because it has, less of a intersection overlap. Now, same thing as before, when you're actually thinking about visualization, because the OTAIR gives you a lot of more flexibility, that also means you have more knob that you have to specify. So typically when you have a visual encoding, there's multiple channels, and we're going to go over that maybe on lecture 3 on the topic, the third lecture on the topic of data visualization. So when you have data, you of course have x-axis value, y-axis value. You want to talk about the color of your mark, which are those glyphs, right? Circles, squares, and so on. Opacity, the shape, the size, and then you can also talk about, the row and column, which we're going to see examples. So for example, in this case, now I not only says I'm going to plot it along the y-axis with the average rating, I'm going to use circle as my glyph. My size of this glyph is going to be proportional to the number of watches. So if a movie has more people watching, it's going to be a bigger circle. So that's what you get, okay? Now, one thing that OTAIR does is actually it looks at your data and it's trying to choose some default for your data type, okay? So whether it's, there's multiple data types, there can be quantitative, ordinal or temporal, and it's going to try to figure out automatically. So in this particular case, again, if we use, say, release date as my x-axis and average rating by my y-axis, you will get something like this. Can someone tell me what's wrong with this plot? Anyone? It's not very ideal because most of your data set, like I said, if you look at release date, right? There's no movie release in the 1600s. Most of the data set is, 20th century. So the default one kind of put all the data points on the right. So what you can do is you can rescale it. So in a way that in this case, I'm saying that I'm not going to 0 equal to false, meaning that I don't want to always orient my data set at the year 0. So if I set it to be that, it's actually much more focused on where the data is actually located, which is sometime passing, around 1920. And then this is how you plot the data. Okay, so remember I have the point, I can replace it by circle, which changes the glyph or change the visual encoding of my data point. And this is what you get. So now your circle, the hollow circle become solid circles, okay? Now, this is a little bit more complicated in the case that not only I'm going to do, kind of rescale it, but I'm also going to specify color equal to genre. And what this means is that I'm actually, well, first of all, I'm going to select 3 different type of genre from my data set, and I'm only going to focus on those 3. And if I do that, it's actually now going to plot, again, this is the same plot as before, except my data point is plotted by the type of movie, the genre of the movie, where children is sort of, blue and documentary is orange. And once you can now do some analysis, because you can see here, around year 2000, most of the documentary has a pretty high rating, and a lot of the sort of horror movie have very low ratings. I think I watch plenty of B movie horror movies. Those are right here. Okay, so now you can also try to treat color as a continuous. Well, the color can be also used to match a continuous variable. When you have 3 types of movies, those are categorical, but the number of watches is a numerical value. So if you actually use numerical values, hold on one second. Okay. So if I actually want to plot the watches associated with each movie, I get something like this. So again, now what is smart about Altair is that it's actually notice watch. So when it says, okay, the genre is a categorical thing, so I'm going to choose a color map that is categorical color map. So blue, orange, and pink. Versus if my watches is a continuous variable, it's a, you know, then I'm going to use this sort of a continuous color map. Okay. Now you can also do binning and aggregation. So in this particular case, what does this look like? This is a histogram, right? So in this particular case, I am going to take my data and I'm saying that I'm going to plot it by count, which basically says that I'm going to learn the data and I'm going to figure out how many bins are there. And based on this bin, I'm going to look at how many records falls into each bin based on sort of the average rating. Okay, so this is sort of Altair's version of a histogram. You can also, of course, control the number of bins in this case. It shows up to 4 bins. Oh, actually 5 bins. Okay. And you can further color it by the genre. So now the difference is that, okay, the difference between those two is that they're still histogram, right? But the thing that those histogram are a combination of 3 different kind of genre. So it's now having those kind of stacked histograms to show the distribution of each genre. Okay, the last bit, you can also, by specify column equal to genre, now I'm going to split this histogram into 3 separate histograms. Because when you select the column, you're just saying, I'm going to only plot the histogram for each individual genre. So just the histogram for all the movies, the children's movie, for all the documentary, and for all the horror movie. Okay. Similarly, it comes with line chart. And in this particular case, I am just, you know, x-axis is the release date of my movie. The y-axis is labeled as my mean average rating, and it's rescaled. Okay. So this is sort of the line chart that you are, and you'll use a command make line. You can also do what's called compound chart, and then this takes a little bit getting used to, and it's kind of special for Altair. So nothing is plotted yet, but what I have created is on top is a histogram, on bottom is a scatter plot. And what I do is I use the V concat, which is basically I'm combining those 2 plots together. So as you can see, I have created a histogram right here by say mark bar. It's really, it's bar chart. And it has some property associated with bar chart. I also created a scatter plot. And I just using this particular command to combine those into one single plotting. So it sits on top of each other. But similarly, there is a special syntax, which is this AND operation right here. This is basically saying that I'm just going to combine those 2. And this is something to getting used to. In fact, what Python does is actually overload this operator. When you specify there's actually 2 charts right here, it knows that what I intend to do is to combine those 2 charts together. And it's going to give you the same results as the previous command. And of course, I can also play them, instead of put them on top of each other, I can put them side by side. You can either use hconcat or using this sort of OR operator right here. And if you do that, you're putting left and right. Okay. And finally, you can put one chart on top of each other using this layer function. So what layer function does is, or you can use the add function. Again, this is another overloaded operator. When your operator, of course, if you just have number, you say 1 plus 2, it's going to return 3. But in this particular case, they overloaded the plus operator so that when you have two charts, like in this case, a histogram, a scatter plot, it knows that we are going to put them on top of each other. So this is what you see. It's actually plotting in the same space. And when you say the resolve scale is independent, it means that I do not want them to be in the same scale. So in a way that the one plot follows the scale on the right, one plot follows the scale on the left. If you don't specify, it's going to try to force them into the same scale. And in this particular case, it's not going to look as nice. Okay. Now, the most exciting part of today's lecture is that Altair offers interactive capabilities that is very different from everybody else. So, so in this particular case, I'm just going to enable the most simple type of interaction, which is zooming and panning, right? Panning means that I can move my data point left and right, and zooming, I can go in and out with my mouse movement. And this interactivity is created by just Altair calling .interactive, right? So if you look at the syntax, everything else is the same. I just created this scatter plot matrix as before, the movie scatter plot matrix, but I use .interactive to make it interactive. So this is why it's actually a very powerful thing, is because you can now create some form of interaction with your plot. Okay, if you want to engage your user with the data a bit more, you create some interactive capabilities. The next one is called selection. So again, what we see here is the real syntax here is, first of all, I'm going to define the interval is a type of interval selection. And you will see what I mean very soon. And I say this chart, I'm going to add selection capabilities. So what does this mean? Is that whenever we say it's an interval selector, it's basically a rectangle like this. So this enables user to draw rectangles and do something about it, okay? Of course, right now I have not specified what I'm going to do with this interactive capability. I just enable selection. But what you can do following this selection capabilities is you can say, well, I have allowed selection as before, but specifically I'm going to use Altair condition to specify what I'm going to do if I have selected my data. So in this particular case, I say, you know, alt condition is to say, well, it's interval, it's selecting genre. Alt value means alt gray. That means anything outside my interval is going to be light gray. So with this small syntax, now if I select data set, it's going to gray out anything outside of my selection. All right. And so on and so forth. Okay. So that's selection. But what about if I combine charts together? Okay, so this is where the more advanced features comes in. So what you see here is I have put two charts side by side. One is plotting of average rating and one is plotting of watches. And each one of them is a scatter plot matrix, right? First of all, what we say is that I am going to label it by release date. They share the same x-axis. One's y-axis is average rating. The second y-axis is watches. And the condition is that each time I select, it's going to be light gray. But the most interesting part of this is that as long as those two charts have the same selection, you are now seeing the sort of combined effect. So that means when I'm selecting the data set on the left chart, the same data point is show up on the right. Okay, same thing on the right. So this is essentially in visualization, this is sort of one of those capabilities about linked views, where when I'm having two visualization, they are somewhat linked underneath, okay? Okay, now you can also combine this with filter capabilities. Okay, so what did this do now? I have, again, average rating combined with watches. So left is plotting of the same data set with average rating. The right is plotting the same data set with watches. And then I'm going to combine it with a third plot with the histogram. Okay, so now what's its capability? If I select this data set, the left and right chart are linked, but then the histogram is also shows up. So it's actually the histogram now corresponding to the histogram of the data I just selected. So now you can see that not only I'm visualizing the data, I'm actually enabling a little bit filtering of my data and understand a subset of my data set using those simple plotting. So in this particular case, for example, I can select the upper right corner, which is the movie that released after around 2000, has a high average rating. And you can see from this analysis, from the histogram, it shows majority of the movie that has a really high rating are documentary. And there's very few horror movies in that region. Okay, so you can see that there's already some interactive capabilities that help you analyze your data set. You can also do the same thing with scatter plot filtering. So again, remember the syntax is transform filter. So again, I can do this. Okay, so what is happening is as I'm selecting more and more data set, I'm on the left, I'm selecting the subset of my data that is within certain range of release date, average rating. On the right-hand side, I am plotting the release date against a number of watches. So you're saying that I'm selecting the ones that is in this range, and I'm going to plot the corresponding data against its release date versus number of watches. So you can kind of enable interactive capabilities. The last one, we're not going into detail. This is sort of my last example today, is you also can do map plotting with Altair. And this is just the first example you can do. So again, I'm not going to all the details, but basically you can use this command called mark geoshape, and you can load data set of a particular format. And then this is showing sort of a plot of a map. Okay, so as I mentioned before, I'm just scratching the surface of what you can do with all those three libraries. And for your homework number 5, there's a few questions, I believe, in homework number 5 that is due next week, contains some of those plotting capabilities. But if you want to learn more, there is sort of additional examples. And for example, for this case, you can also look at the source of this example, and and there's more things that is offered right here. So for the remaining time, I'm going to ask you to form groups, and we're going to do our group exercise. So if you click on here, the 12. So on the online, I'm going to set up some break room. And for people in the classroom, feel free to form groups of 2 or 3 so you can work together. And for this group exercise is to create an interactive chart in Altair. And also remind everybody for this class, we have participation point. So if you have done this, you can upload it through Canvas, so you get a point. Throughout the semester, you can upload up to 5 group activities and you'll get a point. Sometimes we run out of time, so you do it after the class. But today, I'm actually good on time, so start doing this. And before I stop recording, any questions? Okay, so let's see. If there's no questions, I'm going to stop recording.